Okay. Welcome back. After such a long pause, a bit of an unplanned hiatus. Yeah, I didn't really plan to take that long away, but life kind of got in the way after I took a short break for summer. And before you know, it's nearly Christmas. So that's a bit of a shame. So I've not looked at the Flectris code base in quite a while. I've not really got a very solid plan for what to do today, but I think it's getting to the point where I need to do something, or I'm just going to have to accept I never do anything again. Which would be a shame, because it feels like we got to actually the start of the really fun bit, right? We kind of gotten past the, well, I think there's still some more renderer pipeline building, but we've got to the point where we can actually start seeing things. So that's a bit, well, it's something to look forward to. So we're going to kick today off. I've got a little idea for something small we can tick off just to kind of get back in the swing of things. There's a couple of updates to say though. So one is, I've been experimenting with using Emacs instead of Cocoon. I guess maybe I'll ramble a bit later on about what I found with Cocoon, but I don't know. I fancy trying something a bit different. I'm a big Soding fan, and I guess I was just watching him. Actually, it is something he said that made me think I should try out Cocoon. That made me think I should try out Emacs. And he was talking about how good compile mode is. And I was a bit like, I remember trying to get Neovim to do this, so and never quite getting the quick fix window working quite how I wanted it to. So we're giving it a go. I'm just playing around using the pretty basic setup. In this little gap, I've been doing a few little things like the Euler project problems and a couple of Advent of Code problems just to check the setup's working. And it seems to be. So let's see. If we have horrible trouble, you'll know why. Let us just check that actually on that note that we can use compile mode. Let's see. To build this project, because it'll be kind of embarrassing if we can't. So Odin run main, I think, should do it. There we go. And it still lets us resize, which is where we left it off. We've got index drawing working with some handling for resizing. That's kind of it. I do think our README had... Yeah, these are kind of the next big things to do. So obviously our current thing is just allowing us to draw this hard-coded square. We would like to draw a hard-coded square with an image texture applied to it, and then, I mean, that's basically a game, right? You do that, you move it around, you add some interaction, and we're there. That all sounds quite big, and like it's something we're gonna do maybe next time. As for what I'm gonna do right here, right now, the little idea that occurred to me was that I think we have a bunch of places where we can use Odin's multiple returns to give us a tidier interface than the generated wrapper for the C Vulkan library actually gives us. So can I think of an example somewhere in here? Maybe render is a better place to look. So if we're in here, I'm assuming as we look down, yeah, we have all this sort of thing, right? So enumerate physical devices, which we first pass in the count, and then we get the count of things so we can allocate out the memory to put physical devices in. It's a faff. And I think we can wrap those calls up so that here we can just call our own enumerate physical devices function and use multiple returns to pass us out result and count and physical devices. So I think that might be a slightly dull, slightly boring, but easy thing to pick off. And I think if we do a good job of it, it'll make the rest of our time with this project that little bit nicer. So let me just check there's no unintended things floating around anywhere that I haven't got up to date. Everything looks up to date. Cool. Let's see. Does the Odin thing support renaming? it does not support renaming. So my first thought is what we do is we rename VK to say Vulcan. Can I do that everywhere? Can I do this to become Vulcan this? And we'll hit bang to do it everywhere. And if we then recompile, that still works. Sweet. It might be worth us just doing a quick search everywhere. So where else have we got import VK? So everywhere's got this. So I think we do that same trick everywhere. So let's go ahead and do the same query replace, and we bang that out, and we check. You now do not, because it misses this one up here. Check it again, and it works. And I think, can I go back to my grep? It's in xref, there we go. So that was main. If we jump to nya, we can go ahead and say your Vulcan, and this time a lot less stuff breaks, but we can still do it quickly. And we can check it compiles. There we go. So we're going to use the namespace Vulcan for the default one. In fact, actually, that should work, shouldn't it? Yeah, it should do. So let's go back and do that everywhere. So the default name for a package is the name of the directory it's in. So import vendor Vulcan will give us a package called Vulcan. So we were kind of wasting our time a little bit. Unimportant, but a bit of tidying. We do that. Everything compiles. Let's go ahead and just commit that quickly. What is there? Rename VK to Vulcan for vendor Vulcan. And I think the reason I want to do that is I want to use the VK namespace for my own thing that we're going to work on. So let's check out Dired. I think I might just stick it in inside of our main package. If we put it inside the main package, it just gets pulled in automatically. Is that what we want? Or do I want to come in here and I'll make my own VK, and it will have, what do we want to call it? vk.odin? lib.odin? Let's go vk.odin. Package vk. And let's just try. If I come in here and we say import, does that work? Do you have to give it a path? No, does not work. .odin. Okay, let's try in here then. Test defined as B5, and then we'll come down here and we'll say foo is equal to vk.test. It's got to be relative. Okay, does that make sense? I guess, because we're in main, so we have to go back to tell it it's in Flectris, and then it's called VK, and then it's all directory based. So actually, maybe we can nest it inside main to make these just be import VK. Curious if that works. So if we come back to here. Oh, how do I move things? I'm not very good at Dired yet. Come into here, we say move. Move page-wise, move, rename a file, or move the marked files to another directory. Okay. So if we go mark you, then was a capital R, so I want to rename VK to main VK. So we come into here, and we can see all of this. Cool. And then if we come back into nya, did we do it on this one? Did we do it on renderer? Then we can just import VK and Did not find it. Can we restart the LSP? Not found for test. ./vk? I mean, it does compile. I kind of wonder though if it's actually getting ignored. If we go to main.odin and let's go find our main, can we say in here format print line vk.test? This should blow up because vk doesn't exist. And if we import vk and we try again, oops, do save the file. Okay, yeah, that works. Excellent. I've not got anything set up for jumping to an error. It isn't giving me an error, which is fair enough. Where do I actually put it? Should we just undo? There we go. Get rid of that. Get rid of that. So we'll pull renderer back up. We'll import VK into here. And we will go and grab vk.odin. So that's now not needed. And I guess we do one of these and see if it actually is a useful pattern. We're going to have to work out what we call things. We're going to need to import vendor Vulkan for one. So let's go ahead and do that quickly. Do we want to literally just use the same name but use snake case to make it clear that it's my code? Let's see what that looks like. So we go enumerate physical devices. I got devices is a procedure that takes a Vulkan instance. I might be lazy and make this one called V. So can I do a V dot instance? I'll go ahead and say instance, V dot instance. A count. It doesn't take a count, we're going to have to work that out. So it'll just take in an instance and it will return a res. Oh, do we want to return OK? Or do we want to return the Vulkan res? I think we want to return the Vulkan res. So what is that? If we go v dot, I think it's just result. We will also return a count, which is a U32, and we will return to res count and a v dot, or is it a slice of v dot physical device. Do we want to name those? Maybe. If you name them, you can use early returns, but I don't know if that's that useful. So it's a nice pattern. You tend to see people use OK ball instead of like success thing with multiple values. So if as long as you make sure that the 0 value is the equivalent to failing, you can then just early return, and because things are 0 initialized, your named return value becomes the false value, so it gives you a really easy way to do it. It's basically the same as doing if error not equal to nil checking in Go. Okay, so if we do all of this, I think we then literally want to do the same stuff we were doing over there. I'm curious why we defined a res outside of that. Because we're doing 2 calls and I want to reuse the value. Okay. So we get the res, we go and we call v.enumerate physical devices. We pass through the instance. We pass in our count and nil. So if res is not equal to success. So in that we were panicking. I guess what we actually do here is we're going to return a oh my god, what's the values of result? So you know it's been too long. No value found for result. Can I not jump to that file? I can. If I go to enums, can we then look for result? I mean, you certainly can. There we go. Let's scroll that up. So if it's not equal to success, and then there's loads of values. But we actually might want to handle those in a bunch of places, right? So is it pedantic to have an OK ball, a res result, a count, and devices? That seems really dumb and annoying. Okay, so if we do that, we can then return false res. Count will be whatever, that will be whatever. So actually, I think in this case we can early return like this. And this is what I was saying. So okay, because it's a named value up here, this essentially does our declaration that it exists. It gets set to 0. 0 is false. So in this case, you just get all of those values out. And the important point is we can check the value is false. And we know that, well, we know that we need to handle a failure case, not a success case. And we've got the result passed out so we can still get hold of it. I think that seems reasonable. We get the res is not equal to that. Physical devices. Will then need to be a oopsie daisy, a slice of physical device of length count. So it will do the allocation for us inside. I'm curious why we defer delete physical devices. If we do that, okay, I'm going to ignore that for now. So we've done this. We say then res now be, we redo the enumerate physical devices with instance and count. And this time we have a non-nil value getting passed in here, which we can't get rid of. Yeah, so I'm going to say that the caller has to free that memory. So the raw data, physical devices, and then we have our same thing in here to say if it is not successful, then we do our early return. And else, we return true. And we still have to pass out res. That's annoying. Is that even worth doing then? Should we sack this off? Because we've set res, and so if we return, we get result count nil. So actually, I think we get the exact same thing if we do this, right? So let's simplify. We do return res, where got it. We've got count and devs, which should now be valid memory because we've done the thingy. And I think what we can then do, in fact, let me go ahead and just comment this out. Oh, I wish it didn't do this ugliness. Yeah, I hate that. Let's undo that. I was expecting it to do it by lines. Oh, I fucked this up, haven't I? What have we done? For device in physical devices. Do you still run? Yes. Okay, so everything's fine. We're in here, and what we would like to do, if we go grab this back up, is we would like to say res and count and what do I call it? Physical devices is equal to vk dot enumerate physical devices. We need to pass in our global context dot vk instance. I think it's complaining that we're redefining it or declaring a load of stuff that already exists, and that should behave the same way. We are missing a function that we will want. I think we're going to end up wanting it basically everywhere. So maybe we make an helper function to call is success. It'll take in a result. Is that even worth doing? I think so. So we end up doing a lot of these checks. So I think if we have an is success and not success, it makes things a little bit neater. So let's go v result, returning a bool, and we just return res is success. And similarly, we'll do not success, takes a v result bool, return res not equal to success. So let's go ahead and do that. And then in here, we can say if vk not success res, then I think our original behavior, we say panic. What did we say? Failed to pick physical device, or failed to enumerate physical device. It would be nice to pass out res and count, wouldn't it? So maybe we do that first. Format, print standard error. So we just panic fatally, and we'll have an E print line. This will say failed to enumerate physical devices, and we'll pass out res and count. Cool. I think that works for us. We come back into here. Can we have this pass out a dot something suboptimal khr so it blows up? Panic, error, fatal. That's slightly ugly, isn't it? Leaking structure core dumped, failed to enumerate physical devices, suboptimal khr2. I mean, it has everything in it that we need, though, doesn't it? What does it do if I pass nothing in here? Can I do that? No, you have to pass it something. Well, that's not terrible, is it? Just wonder if you want to make a fatal function, 'cause we're going to be doing a bunch of that. I think that's too boring. We're not going to care. Are we going to care? Actually, I'm curious. What's the signature on you? You're an args .any sep equals flush true. Cool. So that's variadic function, I assume. Okay, let's write our own fatal then. So we'll have a thing in here to say fatal proc. We will want that same argument. It's a void function. I think means we can specify. Is it no return? Is that a different language? That might be a different language. I don't know if you can tell, I am beyond rusty. I haven't been writing any Odin, really, in any meaningful sense. What do you want to do then? Format dot e print line. Not imported format, so let's go do that. Import core format, and then we'll have you eprint line, pass through args, and then we will panic with nothing. I'll say VK fatal. So we do that. We now get a panic. We're not called it yet, have we? That was silly. We'll come back in here. Instead of doing this, we can do VK fatal. We can delete that. We run this panic VK fatal, and we can see all our values. Do I need to spread them to get it to print right? Interesting, it's showing them as a list. I don't think it showed them as a list before, did it? Format eprint line. What have I done wrong there? So format eprint line. That takes in a variadic thing, so it all goes into a list. That is then being passed into eprint line. Does that spread them again? So is that what I need to do? Is I need to go VK fatal like this. There we go. And then it prints them nicely as expected. Cool. That probably is slightly better, isn't it? That reads slightly nicer. And then we can go off and do our logic. This device picking, I don't think we're going to touch right now. This one down here, again, you can see, I think basically everywhere that we're doing this kind of business where we're grabbing a count, I think we need to be a little suspicious of. So what actually is the function call in here? Vulkan get physical device queue family properties. And then, my goodness, I forgot how gnarly all this can be. Okay, it is one of these enumerate ones that you have to call the same thing twice. So let's do that in here then. So we go in here and we saw get physical device queue family properties. Do you know what? This might actually be quite a good way to kind of get back into the code base, just because it's going to involve a lot of reading what we wrote before. So physical device v.physical device. What do you want to return? Probably a res, which will be a v result. Account u32. Do I want to standardize on a name like list in these things? So for outputting a list of things, if we just get used to calling them all list. It's clear what it is from the type, right? So what I want to pass out now is a slice of scanning VQ family properties. I think that's nicer because I think they're all going to have this same shape. And it'll just save you, as you're reading it, having to think about what the names are going to be, because they're the same every time. So we're in here. We've got a count. So we're now going to call v get physical device q family properties like so. We pass through physical device. We pass through a reference to count and nil because it's the counting one. Apparently that one can't fail. Oh, interesting. Okay, this one guarantees it won't fail. So I guess we'll come in here and we'll take that out. Just realising actually our logic up here is not freeing that memory, is it? So we do all of this. If that, else defer. Is it delete? Defer delete physical devices. Cool. Then down here, we do that call to get it. We allocate the memories, so we say list is equal to make with a slice of Vulkan Q family properties and count. Then we call it again physical device Q family properties with again physical device and count and list. Do you need to be a raw pointer to list, do you? It's not a raw pointer because that's a type, it's raw data because that's the procedure that gets us the raw pointer. So we do that, and then we return. And again, because it's named, we can just do a naked return and get the values we want. That should work. And so we come in here, we now don't need this. We need to know what that's grabbing, so render a physical device. So we can go vk get physical device q family properties for renderer dot physical device. Then we can go sod that. Do we care about count? We might want count, so let's pass out count and what have we called it? Q family properties. Which is unhappy. Why are you unhappy? So we get our slice of these things. Ambiguous procedure call delete. What have we messed up? Count and Q. Did I call it family, not families? There we go. And we now don't need all of that. This logic, I think, might stay basically the same. So remembering this, we grab the Q family properties to work out which Q on the GPU we're going to send work to. And this is just checking that we've got a queue that supports everything that we need. Cool. So I think we do that. And like I said, I think things that get beyond that really simple, like just enumerate stuff logic, I think we'll leave. So we're not going to worry about them. Check that it runs. Doesn't run because I forgot to set this back to success. There we go, so it still works. Very intense and in-depth testing process we have. Right, so what are we doing here then? So priorities. It's passed into a queue create info. Now, do we care to pull these things in? I don't think so, because this isn't the same pattern, right? This is the just structs containing structs of info that's needed to call create device, but it's not the kind of enumerate pattern that we're replacing, so I think we leave it. Get device queue for all of this stuff. I don't think we touch. There might be stuff in create swap chain, but I think we should go top to bottom in the file. We'll find it later. Create command pool. Again, not the kind of pattern we're looking for at the minute. Allocate command buffer. It's a different pattern. Create vertex buffer. Has a create info, buffer create info, so it's a different pattern. Allocate vertex buffer memory and bind it. Again, I think it's a different pattern. I don't think there's any enumerating, it's just... That's interesting. Why is this one done like this? Do you return a value? For some reason it's defined over here. You are a proc system. Doesn't return anything. Right. So it can't fail. I wonder why they do it like that then. So normally they do this sort of thing because they can't return. Oh, I guess they can't return it because they don't know how big it's going to be. They do, because it's just a struct. Oh, I'm so confused. Get buffer memory requirements takes a device, a buffer. Okay, so it's not an enumerate pattern, but it looks similar to me. Can we do the same kind of thing? Can we come in here and say, get buffer memory requirements will be a proc that takes a device, which will be a v device, and a buffer, which I think will be v buffer. Oopsie daisy buffer. Like so. And we will just return our memory requirements. So we can make it named, we'll call it memrec, memory requirements. What's your type? V dot. I'm not very used to the key binding just yet. V dot memory requirements. We come in here. I think we actually then just literally call that same thing, right? We call get buffer memory v dot get memory requirements. Pass in a device and our buffer and a pointer to memrec, and we return. And that should work, and it can't fail because it doesn't return us anything. I still find slightly baffling. Whoops, let's take that back to here. But that means this can then be a single line. What we're doing? Memory requirements will be equal to vk.get buffer memory requirements for renderer device, renderer vertex buffer, and nothing else. And we can avoid the in-out. Check that runs. Put them side by side again, but yeah. Lovely. What's next then? So memory properties. Get physical device memory properties. This looks the same, right? Get physical device memory properties. So proc. What do you take? Device and nothing else. So we just take in a device, device, v device. We'll return a memprop of type memory, no, of type physical device memory properties. And we'll call this get physical device memory properties. We'll pass in, so this was actually going to be a physical device. A physical device and memprop, and we'll return. So very marginal gain, but hey, fingers crossed this actually makes it better. There's a chance this actually just makes it that little bit more annoying to read. I'm hoping it removes a bit of guff that makes it all unnecessarily verbose. Memory properties will actually now be vk get physical device memory properties for our renderer physical device. Check it runs, and it does. All is well. Cool. So we've got our memory requirements. We get our memory properties, get physical device memory properties. We now don't need. And then desired memory type properties are the ones we do want. Memory type index is -1. We do some iterating over memory properties, memory types. Jinkies, what are we doing here? Physical device supports resource type. Physical device supports resource type. Memory requirements, memory type bits, ampersand, that value shifted is not equal to 0. Supports desired memory properties, checks that it's a subset of property flags. If supports desired thing, we set memory type index. If memory type index -1, okay. That looks like the sort of thing we're going to do in one place. So we're going to just leave that be. Is that true? Because we allocate more than one buffer. This might want to be wrapped into a function, but we'll do that in a separate sweep. We allocate, which again is not enumerating, so it's a different pattern that we might want to play out later, but I think we call it good for now. We bind. We map the memory, which again is different. We copy the data over to it, which is different. And then we do the same stuff again here. So we create the index buffer. This whole block of nastiness is done again. But now we can make this that little tiny bit nicer using vk get buffer memory requirements. Renderer dot device and renderer dot index buffer. This is where maybe we are suffering slightly for me stubbornly not pulling things out into functions we went, but I don't know. I still kind of stand by it. I feel like when you're writing something you understand so little of, it's not a bad idea to err on the side of just writing it top to bottom. And we can come back and do this tidying after. I mean, does this take that long? Oops. Where we actually were, we were up here. Renderer dot physical device. Then we don't need that one. And the rest of this stuff is repeated, but hey ho. We'll worry about that in the next load of tidying. Do we copy the index data? Cool. Check it runs. Still runs. We should probably be checking it still resizes each time, but yeah, there we go. Right, so what are we doing here then? So we've copied over the vertex and index buffers, then create the vertex shader module, data error equals os read entire file from file name. If the error is not equal to nil, then it dies. Cool. We do create info, we call create, not enumerating, not interested. We repeat for the other shader. We then call a function that is further down, that was pulled out because it's needed to handle resizing. Create synchronization objects, I don't think is any enumerating. We'll scan through it quickly though. Semaphores draw finished. For this draw finished, semaphore res, create semaphore. So one thing we could do is we could make this a function that returns the res and the value it gives us, but I'm not sure it gives us any advantage in this case, because we'd still have to do this. Still have to pass all this through. Yeah, I don't think it does. Not enumerating. It's specifically that enumerating pattern that I think is particularly bad for reading, because you have to kind of do the call and then do the call again, and it's just a lot of text to get through for not a lot of information. Image acquired, fence create info. We create a fence, gets the res. Then another fence create info, frame finished res is equal to this. Ah, you're not used anywhere. Get references, yeah, it's not used. That was an error. So if frame finished fence res is not a success, then panic, failed to create a whoopsie daisy frame finished fence. And it gets to the end and it returns its renderer. So actually, that wasn't too bad. All of this guff, I think, is just a load of destroy calls that we don't have to worry too much about. Alright, draw frame. I don't think this is likely to have too much of this pattern in it either, right? Well, I'm still kind of curious, because like I said, it's been a long time since I looked this through. So draw frame is a proc renderer. If the window's resized, we handle screen resize and we return, so it does nothing. We skip that frame, I guess. Ensure previous frame finished before we start. And we reset the fence so that we don't end up stuck waiting for it. Get the next swap chain image, acquire next image. Right. Handle the cases that tell us if swap chain is out of date. Cool. Then we wait for fences for the image acquired fence. We fail if it's not success. We reset that fence. We fail if it's not a success. We begin our drawing. This is actually, now I'm reading it through, another thing that I was thinking. We've enabled dynamic rendering and then we've not used it at all, right? I think we're still doing things in the kind of old-fashioned way of set everything up and then do all your rendering. I don't think anything we've done so far is too hard, but that's something we might want to go back and revisit. Actually, what does dynamic rendering give us? It's interesting to see that the Vulkan people have moved away from their original idea they went with. I assume because actually it turns out to be too much of a pain to actually do, but who knows. Alright, so there's no enumerating in there. Defines clear value, defines the color attachment. That, I guess, gets passed into this, does it? Memory barrier transition to fragment shader output writable. Oof, what does that do? Memory barrier to write. It's an image memory barrier. Color attachment right. Old layout is undefined. It becomes a color attachment optimal. Source queue family index, destination family queue index. Sorry, queue family index, image, the swap chain. So yeah, we are putting the swap chain image into a memory layout that allows it to have the image written to it, if I'm reading that right. Vulkan command, pipeline barrier, source stage, dest stage, color attachment output, image memory barrier count, pass the image barrier to right. Oof. Memory barrier transition to presentable. Okay, I've still got kind of the broad strokes because this makes sense then. So we've made it into a thing we can write. We write to it. We make it into a thing we can present. We present it. That doesn't sound too bad, but I'd be lying if I said this all felt like it was rushing back to me. Let's just keep plowing on. So here we define our rendering info, which I think is the stuff we need for dynamic rendering. Render area, layer count. Again, there's no enumerating in any of this. We're just kind of reading it for the sake of reading it. We bind our vertex buffers, we bind our index buffer, we do a draw, we end rendering. That's how we draw a square. Nice and easy. End the recording command buffer. And if it fails, we panic, submit commands. None of that's got any enumerating in it. We present images. And again, if it fails, we handle the cases that mean we've just got an out-of-date screen because we've resized. Grand. Create swap chain. Do you can this call fail? It can. Which is why we're doing this. So this might be one to do. Again, it's not enumerating, so we could skip it based on what we've said before, but I think the same as these, it's just that little bit neater to not have the in-out. So let's do that. Get physical device surface capabilities is a procedure. You, sir, take a physical device, which is a physical device, and a surface. I can't remember, actually, what type surface is it? Literally just VK surface, or I think it might have KHR in it. Surface KHR, cool. So you're a VK surface KHR, and it will return us a so I want to call it res. I think with the same logic as I had before, it feels a little bit like I want to make these names all the same every time, but res I'm kind of reserving for result, aren't I? So let's just not. Let's call this caps. It's a V. It's not physical, it's just surface capabilities. KHR. And then that declares our value so we can pass in the reference to it. And we can then naked return. So we can now V get physical device surface capabilities KHR for our physical device and our surface ampersand caps. Beautiful. And then this one up here becomes all of this stuff. It goes away and we go get physical device surface capabilities. Do we put the KHR on the end? That's an interesting question. I think we probably do for idiot proofing, because I will forget. And then we stick our renderer physical device, and we stick our VK surface, and we tidy that up. Excellent. And that should still work, and it does. Now, this looks like an enumerating pattern, doesn't it? Get physical device surface present modes. Come back in here. Oopsie daisy. Thought it was in the other one. Create swap chain. Is doing this. So we come in here and we'll make a get physical device surface. Oops. Present modes. You a KHR? You are a KHR. Proc that takes a physical device, and a surface, the surface KHR, and you will return, I think, a count and a res, and what else is it? A list of slice v dot present mode KHR. Grand. Now then, what do we want to do? We can say, sorry, hang on. We can say that our result is equal to v get physical device surface present modes KHR. For it's not renderer physical device, it's just physical device and surface and count. And we can use our own is success and is not success, can't we? So if we're in here, we go if not success res. We return. I think that works because res should just be set at that point. If not success res, return. That means we've now got a valid count. So we can now go ahead and set our list to be equal to make the present mode KHR with count, and we can get supported present modes res 2. We can go ahead and say res is equal to v get physical device surface present modes KHR for physical device and surface and count and raw data list. And we now return all of that, no matter what we got. Is that what we're doing in the other ones as well? If not success, we return count. That should actually work the same as this, right? And this get thing. Hold on 1 second. Have a sip of my tea. Throat's going. It's a problem. Spend all day yapping at work. I need to finish and be yapping when I get here. I've done that wrong, haven't I? I think we could just do this. Yeah, that makes sense. We get things. We naked return. And they get in here. Gets the list, gets the res. It doesn't need to check it, because whatever the values are, we return that seems okay to me. Surface capabilities is equal to all of that. I don't know why I've given it a full name there, but maybe it's needed later. So supported present mode count and what do I call it? Supported present modes will now be equal to vk get physical device surface present mode khr with renderer physical device and surface. Which means we now don't need all of this. We're not getting the res. So we can now say in here, if vk.notSuccess res vk fatal, all of that with res and count. I'm slightly confused why we didn't just call it count, so I'm going to come back in here and just call it count. It's what we do almost everywhere. I'm going to see if that breaks anything. If it's not success, that we now don't need. We do still want the delete. Supported present mode does still care. This we can get rid of. That we can get rid of. And then mailbox supported is false for supported mode. If this, we get the present mode. And then there's another count. That's why we were calling this something else count. So supported present modes count. Presented, supported present modes count. Defer delete, we do all this checking. Present mode is mailbox if it's supported, else it's first in, first out. Nice. Is this a different thing? Physical device surface present modes. This one is physical device surface formats. Okay, so we've not done that before, so let's go and add it as well. Get physical device surface formats. KHR procedure. Taking a physical device. Do you know what actually we've not done is we've not checked that still runs. Aha! Redeclaration of res on 682. Interesting. Where is 682? Is this why I'm being more careful with my names in these things? Ugh. So what I want to say, this should not actually get any further than here, right? But we need these values further on. So they can't just have really dumb names. So let's call it supported present modes res. It turns out pass me was doing this for a reason. Supported present. In fact, can we be smarter? I think I can do that. I can drag. No, I can't. Okay, never mind. Supported present modes res and supported present modes res. I'm sure Emacs will have a way to say do the same insert I just did, but I've not learned it yet. The pain of changing to a new thing. Right, do you now compile? Yes, beautiful. So we are now down to here. I suppose we should be a little more careful with these counts and stuff then. So we won't do so much renaming, but we will continue on this journey. So we're going to have a physical device, we have a surface, which is a v.surfaceKjar. I think that's all it has, and then it'll have a res, which is a result, a count u32, and a list, is it? Yep, another list, which will be a slice of, Vulkan surface format kjar. Right then, what do we do here? We would like to call res equals v get physical device surface formats kjar with physical device and surface and count and nil. If not success, res, then nope, not fatal, because I'm going to let the app code handle that, and this is just going to forward it on. We've set res, so we just return. We get to this point, we can do list is equal to make a slice of Vulkan surface, surface format kjar length count. I've made a boo-boo. What have I messed up? V dot. There we go. So it allocates that memory. Res is now the same thing again. Device surface format plural kjar with the same arguments, except this time it'll take a raw data to list. At that point, we can just return because it's got everything on it. Everything is in the named return. We can come back in here and we can go, don't need this, get supported formats res, and supported formats will be equal to, and instead of all this, it will be equal to, what is it equal to? We've got supported format count, vk get physical device surface formats kjar for renderer dot physical device global context dot, oh my god, is it called surface dot vk surface. Is that your lot? Missing a comma. If vk not success for that, then vk fatal, we will pass in our supported format count and our get supported formats res. Then you're not needed, you are needed. All of this isn't needed. Should compile. Lovely. Okay. Let's have another sip of tea. How far through are we? 600 lines. Okay. We knew this was going to be a bit brain numbing. I mean, this is honestly why we picked it up, is I'm not in the mood for thinking at the minute. So what are we doing in here? Desired format support is false. We scan it to see if we find it, and we either use it or take the first one. Neat. Then renderer surface extent is set to the capabilities current extent. So we store the size of the screen. We make our swap chain info. We probably need to go through at some point and replace all of those, don't we? I'll do that separately because I think we can do it really neatly. Ooh. Why is that formatted like that? Is that something we've done in this set of changes? No, it doesn't look it. So I think that does the same as this, right? Confusing. Swap chain image format. Get set to format. Okay. That looks like it's what we want. This one. Create swap chain images. Takes a renderer. Get swap chain images. Get swap chain images. So yeah, we've got another enumeration pattern that we would like to get rid of. So we're going to have a get swap chain images KHR, which will be a procedure. This one takes a logical device. And a swap chain. I can't remember if it's... Is it like that? I'm guessing it's that. And we'll do the same thing again. It will return a result. So v.result will have a count, which will be a U32. And this one also returns a list, so we will call it list of v.image. We're in here, we're going to do v get swap chain images khr. Res will be equal to the output. Passing in device and swap chain to do our enumeration. If not success, we early return. Else we keep going and we say the list is equal to make a list of the... Are they just image? Yeah, they are just image. Because we now have a valid count, we can do that. And we can say here res is equal to v dot get swap chain images khr for device and swap chain reference to count and the raw data for list. And we return. And we come in here, we can kill that off, and we can say res and count and... Ooh, can we just do swap chain images straight away? So in the case where we've failed, we're going to fail fatally. So I think we can just go ahead and do this straight away. I don't think it'll complain. We can test it and see. vk get swap chain images khr for renderer.device and renderer.swapchain and nothing else. Yeah, it's not happy with that, is it? Variable definition cuckoo. Okay, I'll tell you what we do is we do that there. We do an if vk not success for res, then vk fatal message is failed to get swap chain images with res and count. Else So this can't do the freeing because we need this stuff to survive outside this function. We would like to set renderer.swapChain images is equal to swapChain images. That should do the same as all of that. We can tell it works because resizing still works. Beautiful. This one, it's looking like it's likely to have the same sort of thing. Create swap chain image views, takes a renderer. Swap chain image views make... maybe not then. Because this one can just use the length of swap chain images to do it in one go. So that's nice. Then it just does a create. Very nice. Okay, cool. Creating the graphics pipeline is a bunch of structs with details on how we make everything. I think we just scan, but I don't think any of this is going to need to be touched. Color blend attachment. Create the thing. Yeah, we didn't need to do anything in there. Handle screen resized. Wait res is device wait idle. If not success, fail. For I in this. Destroy image view. We tidy up all that memory that we pointed out we weren't tidying up. We destroy the graphics cards, resources. We call all that other stuff, and then we set our global flag. Excellent. That's that file done, I think. What is the damage? If we come back in here, and we just stage everything. How long did that end up being? I mean, actually, not long at all. So maybe we didn't make as much of a dent as what I thought it would. But I think the diff kind of speaks for itself, right? It has made chunks a little bit simpler, and that's a good start. Yeah, it's not very much really, is it, in the grand scheme? Never mind. Refactor, wrap, enumeration and in-out. It's not the right word, is it? Arguments. Functions with in-out arguments. Using multiple returns instead. Right, there we go. We've officially done some work. So the project is not abandoned. We're back in business. I am going to have a quick check. I don't think... What are our other .odin files? Vertex.odin won't have anything. Yeah. I don't think main.odin will. I think the giveaway is anything that says count. That's not the thing I want, is it? Yeah, it's a create info. Yeah, so it doesn't look like there's any of them in main. Main's only tiny anyway. So I think that's done. I think the other thing to look for is these things. So I think we might want to do a check everywhere for things that say something not equal to success, because this we can now replace. In fact, actually, go and import VK. Success. We can now do. Are there any more of these? Oops! Jump to the end. No, I've messed it up, haven't I? We want to go to main. Come back down. There we go. So if I find everywhere we're doing that, I go like this. It finds no more. Good. Ooh, if error not equal to dot success. That does feel dodgy, doesn't it? Alright. If we do that, we can now do VK not success like this. And I think we would like to say res instead of error in there. Cool. That looks like it worked. I'm not convinced that I didn't mess up my multi-cursor stuff though, so let's have a quick look. Import VK. That now says res. Oh, it's not breaking lines like I would like. If we keep going over here, VK not success res, and VK not success res. Cool, we didn't mess it up. Let's go ahead and do the other file that's going to have millions and millions of these, which is to say renderer.odin. When we come to the top, can we do this with one quick thing like we did that one? So if we do a search for everywhere that has a dot success, it's not quite query replace, is it? If I do query replace, I can just do that one. Is there a way to do multi-cursor where I just do a big select? There probably is, but let's do the dumbest version of this and we just go. What do you mean there's none? That literally can't be true. Oh, what went on there? No, that's what happens. I'm trying to be too smart. I've cocked it up, haven't I? What have you done? Res 2, get swap chain images. I don't think we want that. I think that was unintended. Alright, let's try again. We do a search forward for get all of these. Grand. Now we've got that. Bugger. Okay, try again. Dot success. We'll try and do vk dot not success like this. Oh dear. Oh, it's all cocked up. Okay. Never mind. Put that back. Not modified anything there. How did that go so badly wrong? This should be easy, right? I want to select that word. I hit my multi-cursor thing a whole bunch. That found as many as it could. Then I want to go back, grab. That didn't work. Come forward. That didn't work. Do we risk it? We just do this. We put a bracket. We go back. VK dot not success. We save it. We run it, and it's fucked. Okay. So it's the renderer one. And yeah, it was that little bit where we moved around. Okay, we're going to try and do it cleverly one more time. And if we fuck it again, we're going to just do it really dumbly and slowly. And I will apologise for my incompetence. Let's grab that. Right. So we're at the top of the file. We jump forward to find the first place. Oops. Okay, let's do dot success like that. I'm going to grab that. I want to grab all of these until it stops saying mark said and it says no more matches. Once we're there, I can clear dot success. I can go back, which I expect to always work. Put in a bracket, jump back, vk dot not success res. No, didn't work. Ah, I see. Because if it's got underscores, it jumps to the underscore, not to the start. Okay. Right, we're not going to do it cleverly. It turns out we're going to do it kind of maximally dumbly. Kill this. Yes. Come back here. Find this place and we go, if not success, res, do the thing, dot success. If vk not success, res, do the thing, dot success. We go ahead and we do vk not success, res. On to the next one. We go ahead and we do vk dot. Oh, maybe I should copy this. I'll go vk dot not success, because almost all of them are going to have the same thing here, aren't they? Can we go dot success in there? We bin this. We paste that. We go find the next crash dot success. We bin. So you're now bind res. We find the next dot success. We grab that. We find the next dot success. We have a bind res. So we have to come back in here and bind res. We go find the next dot success. It's a simple one. Oops. So we can do that. We find the next dot success. Riveting content. I hope the takeaway from this is that I am highly capable and worth listening to. If not, exceedingly entertaining. Dot success. You're another annoying one that we can't just do. So we wrap it. VK not success. Dot success. It's another annoying one we can't just do. So actually, yeah, there were loads of these that we couldn't do with that little trick. VK not success. Is this worth the effort? If wait res VK not success. Or save me typing some capitals. Another one that we can't just do, so not success, all of that. Dot success. A simple one. Dot success. Not so simple one. VK not success. Dot success. Another not so simple one. Could I have done this in Vim with a macro? Probably. This is the issue. I'm better with the Vim motions than I am with moving around Emacs at the minute. But I was going to say, how do you learn if you don't do things? But I'm currently not learning. I'm just doing it a dumb way. So maybe that was a good time to chat a little about why I didn't get on with Cocoon in the end. And I think it might literally just be down to I'm now an old man with responsibilities beyond myself. And so spending hours just tinkering with my Cocoon setup wasn't really on the cards anymore. And it was all just a bit too DIY. Which is a funny thing to say, 'cause I do like DIY. But it does take it to extreme, and I think it gives me more, what would the right word be? I guess appreciation. I think I saw a John Blow clip where he's talking about how the problem with Linux is because it's just this huge... Hey, we got the last one. It's this whole like ecosystem of lots and lots of tools all sort of garbled together. That you end up having... sorry, hang on. If not, access res. I can't remember how to make it uppercase. No, it can be done. There we go. Cool. That feels a useful little bit of tidying. I can't remember how to do this. Oof. I'll look that up after. There we go. Sorry, what was I saying? Cocoon. I saw a John Blow clip a long time ago that I didn't agree with at the time, where he was saying his issue with things like Vim, and I don't think he knows about Cocoon, but if he were to try Cocoon, I think his issue he'd have with Cocoon is anytime that you've got this kind of distributed system of programs all running lots and lots of different bits that all come together to give you a piece of functionality, what you've done is made it really hard to debug if something doesn't work just right. And I think the main paper cut I found is it meant if a thing wasn't quite right and you killed, you know, I don't know, your LSP server, or you killed the Cocoon server, or any one bit, really I ended up having to make like a script that was kind of just tear down everything and start it all up again script. And it was just frustrating to have to go and call, right? Or to be on a call with somebody, you're happily working away, and then a little thing didn't quite work. And because there's a number of moving parts, it wasn't like, oh, Emacs didn't work, I just need to go and, you know, like Control H, Control F to find what the function is so I can do the thing manually because my keybind isn't there. Which made me think I might like an experience that is still configured in code and is still highly customizable, but is more self-contained. So we're in Emacs now. I could have gone back to NeoVim. I probably will end up trying NeoVim again in the future, but I wanted to try Emacs. I think my NeoVim config ended up using Oil, which is a Dired. Is it a clone? I guess we'll say inspired by Dired, and Fugitive, which is inspired by Maggot. And I was like, well, if the shoe fits, maybe I'm an Emacs user at heart. So I've been enjoying it so far. It's been a nice time. I think that might be our refactoring for today. So not any functional change, but slightly tidier. I would say mostly a spiritual win in that we've touched the code base again after such a long pause. I do have plans to come back and start doing this more regularly again. I think the next steps are probably go and grab a small image and apply that image as a texture, and then add blending so we can get transparency. Essentially we're going to be making a little sprite based game, right? We're going to have little quads that we apply textures to, and we're going to need transparency so that we don't only have squares. But yeah, I think we can save that for another day. So I'm gonna call it there, push all this up to the repo. I hope if you made it this far, you've had a good time, and I will catch you on the next one.